Hello dear learners, in this tutorial we are looking at concept of length and perimeter. So by the end of this tutorial we'll learn how to use Pythagoras theorem, sine, cosine rule to determine length and distance. We will learn how to determine length of arc of circle, perimeter of sector, and as well we'll learn how to determine distance along latitude and longitude. So let's start. In this problem here, we are to find the perimeter of the figure below. So looking at this figure below, this is a right angle triangle. And remember that perimeter is the addition of all the sides in a plane figure. So we have the perimeter of this to be 10 plus x plus 14. Looking at this, it means we need to find the value of x. So to find the value of x, recall that whenever we have two sides of a right angle triangle and we are asked to find the value of the third side, we make use of Pythagoras theorem. Pythagoras theorem. Remember what Pythagoras theorem says? Pythagoras theorem says the square of hypotenuse side is equal to the square of opposite sides plus the square of adjacent sides. So here the hypotenuse is 14. That's 14 squared equals opposite, which is x. So x squared plus the adjacent, which is 10 centimeter. That is 10 squared. 10 squared is our adjacent. So if we square 14, that becomes 196 equals x squared plus 100. So we collect like terms, 100 no longer square, 100. So if we collect like terms, the positive 100 comes to the left hand side to become negative 100. That becomes 196 minus 100 equals x squared. So this becomes 96 equals x squared. So what we then do is to take square root of both sides. Remember, if we take square root of both sides, this becomes square root of 96 equals, why this one will cancel this. Taking square root of this side cancel out the square x. So in doing so, here we have to determine the square root of 96, which gives us 9.79. That's our x. Now that we know that x is equals to 9.79 centimeter, 9.79 centimeter, we can therefore say the perimeter of this figure will be 10 plus 9.79 plus 14. So addition of all these will give us 33.79 centimeter. So we've been able to make use of Pythagoras theorem to determine the perimeter of this. Good. Let's take it a step further. We are given this problem where we have an arc of a circle of radius subtends angle 105 degree at the center. We are then to calculate the length of the arc and the perimeter of the sector. For us to do this, let's first try to sketch out that sector, if this is the center of circle and this is the radius, this is also the second part, and this form the arc. So if what we have here becomes O, that's the center of the circle, A, B, that means the length of the arc is this part AB. That's the length of the arc. And the angle between this sector will give us 105 degrees. That's from the question. So we have to calculate the length of arc, which is what we have as L, the arc AB. Remember that the length of arc equals theta over 360 multiplied by the circumference, which is 2 pi r. In doing so, this becomes 105 degrees divided by 360 multiplied by 2 multiplied by the value of pi. Pi is a constant value, which is ratio of 22 to 7 multiplied by the radius. The radius of this is 13. So multiply that by 13. Now moving on, this we will then have something of saying L will be equals to, you multiply all this, that is 105 multiplied by 2, you multiply 105 by 2, multiply by 22, then multiply by 13. That gives us 60,060. Then you divide it by, when you multiply 360 by 7, which is 2520. Now we can say the 0 at the end, this cancel this. So we are now going to be saying 6006 divided by 252. That gives us 23.83 centimeter for the length of arc. Therefore, the length of the arc is approximately 23.8 centimeter. Interesting. So the second part of the question is asking us to determine the perimeter of the sector. Remember that perimeter of sector is equals to length of arc plus 2 radius. So we don't need to be solving for this length of arc again, since we have done this here. So we just put in this value, 23.8 plus 2 open bracket 13, and that gives us 23.8 plus 26. Addition of this together gives us 49.8 centimeter. So with this, we've been able to successfully determine the value of the perimeter of that sector. Yes, that is interesting, right? Great. So let's take another example. Here, the question says the length the length of side QR of a triangle PQR is 14.5 centimeter, with angle Q being 71 and angle P being 57. We should find the length of sides PR and QR. Let's try to turn this problem into diagram. The length of triangle being, so this is Q, this is R, which gives us 14.5 centimeter, and angle Q gives us 71. Angle Q 71, right? Let's 71. So if this is angle 71 degree, so this is going to be P. Then we can join this. Angle P is 57 degree. 57 degrees. We are to find the length PR, let's call that one small q, and length QP, let's call that one small r. Whenever we have a problem like this is not a right angle triangle. Since it's not a right angle triangle, we solve this problem using sine rule. Why choosing sine rule? We only use sine rule for a non-right angle triangle, and sine rule is used when we have a angle and the opposite side, and any of the angle or side from the remaining part. So sine rule, using sine rule, which says that since we have this complete angle and the opposite side, that will be side P over sine of angle P equals, so we are going to do this first, equals Q divided by sine of angle Q. Now that is done, we can move on with our calculation to say what is our P, that is 14.5 divided by the sine of P, that's sine 51, equals the angle of the side of Q, we divide it by the sine of Q, which is sine 71. Here we cross multiply to make Q the subject. It becomes Q equals 14.5 multiplied by sine 71, all divided by sine 51. So our Q will be equals to, using our 4-figure table, we can determine these values of sine. So it becomes 14.5 multiplied by the sine of 71, which we can check that from our 4-figure table. It happens to be 0.9455. So divided by sine of 51, that's another one, which is 0.7771. So altogether Q will be equals to 14.5 multiplied by that value of sine that we've gotten here, 0.9455, that gives us 13.70. We divide it by this 0.7771 divided by 0.7771, that gives us Q is equals to 17.6. So Q can be approximated to 18 centimeter. That's Q. Now the other side that we need is R. For this now, we are interested in finding R. We have gotten Q, and we do not have the angle of R. How do we go about that? To get this angle of R, remember, this is sum of angles in triangle. Sum of angles in triangle, we can use that method. So adopting the rule sum of angles in triangle, that means Q will be equals to 180 degrees minus 51 minus 71. That gives us, when you subtract all this now, negative 51, that is, you subtract 51 from 180 first. When you subtract 51 from 180, you should get 129. 129, then you now subtract 71, you will get 58. So 58 degrees is the angle. Now that we know that, we'll perform another sine rule, or better still, we can use cosine rule, as the case may be. When do we use cosine rule? We use cosine rule whenever we have two sides and the angle between them. Two sides and the angle between them, we use cosine rule to determine the third angle. So for us not to forget, let's remember that we've gotten the value of Q to be 18 centimeter. So if we are to use cosine rule, let's try that out. You remember what your cosine rule says? Here now, our interest is to find side. So cosine rule using that side tells us that the side that we are looking for, that's R squared, will be equals to square of Q plus square of P minus 2PQ cos of angle R, which becomes Q square, that's 18 square, plus P, which is okay, we are using approximated value, so it's advisable to just not use the approximated value. For now, let's use the calculated value, which is 17.6 all squared plus the P, which is 14.5 all squared, then it's going to be minus 2PQ minus 2PQ, that's what we adopt, minus 2 multiplied by 17.6 multiplied by 14.5, still multiplied by cos of the angle R. Remember, we have gotten the angle R, here what we have gotten here is angle R, not Q. We've gotten angle R to be 58 degrees. So that is going to be square of what we have here. Let's completely clean this so that we do not mix it up. While we are doing that, you are looking for the square of the angles that we have. That's 17.6 squared, which gives us what? You square it, so 17.6 squared. That gives us 309.76 plus, we square this 14.5 squared. That gives us 210.25 minus, then we have to look for the product of 17.6 and 14.5. So the product of these three terms gives us 510.4. Before we now multiply by the cos of angle 58, which we can check from our 4-figure table, cos 58, right? It gives us 0.5299. Now that we've been able to do this, the next thing for us is to completely simplify value, to completely simplify it, which we can do very fast. In simplifying the value, it becomes, let's not forget that when simplifying, we only add these two terms together. This and this, we add them together, leaving this one because this is jointed by the sign multiplication here. So we are left with 309.76 plus 210.25. That gives us 520.01 minus, when you multiply this, 510.4 to be multiplied with 52, that is 510.4 multiplied with 0.5299, that gives us 270.46. And we take the difference of this 5, that's when you subtract 270 from 520.01, what do we have? We have 249.55. Remember, it is r squared that we have just gotten. So the value of r itself will now be square root of 249.55. Here r becomes 15.79 centimeters. Therefore, we can say r is approximately 16 centimeters. So we've tried out sine rule and cosine rule. So if you enjoyed this video, don't forget to subscribe Leave your comments till we come your way next time. Enjoy.